So we've got to draw the sketch of y equals sine 2x, okay, just that, alright, sine of 2x, for 0 to 720. Now, the thing in front is the amplitude is a 1, that's why there's no number there, and then it's plus 0 at the end, if you want, but we don't put it. So if I was going to do my sketch, obviously then, my centre line is still the axis, right? My amplitude is what? 1. So I'm going to go, and again I've not labelled my axis, so I'm going to go do a line there above and below. But what's important is I label that 1 and minus 1. Okay, so as long as you've done the 1 and minus 1. Okay. Now we know it's sine. So normally sine starts at 0, 0. The next time it's at 0, 0 is 180, 360. Right? However, that is where one wavelength should fit by 360, one sine wave. However, this 2 means what?
2 wavelengths in 360.
2 wavelengths. So what I'm going to do, I'm going to draw a dotted line there. Okay. Now I've got to fit it in there. So I've got to fit 2 in 360. So instead of having 0, 180, 360, I've also got to half those values. So it now be 0, 90, 180. Now from there it goes up to a maximum at 45, down to a minimum. So my first little wave will happen like that. And then it will continue to happen. Okay. And after 360, the same thing happens again. So max, 0, min, I can put them all in for the remainder. So your chart, your graph of this function should look like that.
Do we do both of them on the same axis?
Yeah. Oh, well, the sine one.
Sine x and sine 2x.
Yeah, but do you remember what I said right at the beginning? You didn't have to draw the sine. Alright. Sine, if I were to draw the sine graph, the initial one, that will look like, well, okay, so normally sine, just sine will look like that, won't it? Okay, but I did say no, it's not necessary to draw, okay, at this stage. So my graph is all we're going to look at, just this discussion point. I've drawn the 2 curves there, okay. I've got sine x and I have sine 2x. Okay. Now, if I said to you, solve sine of x equals sine of 2x, where x is between 720 and 0, how many solutions will there be?
0.
How many solutions to sine of x equals sine of 2x? 2, you think?
4.
You think 4?
0.
0.
8.
8?
How sine x equals sine
4.
You think 4?
2? 0.
0?
5 gems. No, because How is sine x
Which
equal to
was-
sine 2x?
Yeah, how does it?
How is it?
It can't be.
Really?
I don't know.
When
Yeah,
two...
four.
Go on.
Four.
Is it when they cross over?
Yeah, it's when the graphs
Zero,
meet.
Ah.
So
zero,
we've got-
180, 360.
So minimum we've got 1, 2, 3, 4. That should
Oh.
cross.
Oh.
5.
Yeah.
However,
So
Six,
in,
seven,
infinite?
6,
7,
7,
8,
8,
9.
9.
Between 2 and 3.
Okay?
Ah, I get it.
So there will be 9 solutions. Now, obviously, if I were to ask you to sketch those accurately, and you've got points, I could also ask you to estimate the solutions. Your calculator can find them exactly, but I wouldn't ask you what the solutions were if it was a rough freehand sketch. Okay? But we know, for instance, that the solution will be somewhere between what and what. If I were to ask you to estimate that, what would you tell me? Pardon?
40 and 60. 65.
Well, it's going to be more than 45,
Oh, yeah.
less than 90. So if you put 40, you'd be wrong, you'd be marked wrong, because you have to know that it's above 40. So somewhere around that sort of, it's probably what's halfway between 45 and 90. So it's even going to be less than that, potentially. But anyway, the point is you could estimate what the solution would be. We do know some definite solutions. They would be what? 0, 180, 360, 540, 720. So we've got those definite ones, but then these other ones we might estimate. Okay? But that can show you where you could find where one function equals another. And that's another way to write that would be f of x equals g of x. Okay? So if I told you that sine 2x was g of x equals, and f of x equals just sine of x, those points are f of x equals g of x. You will see that coming up. Okay? So that's how you can do it. Right? And that's how, if you know your sketches, you can also figure out just how many solutions there are by sketching those two graphs. Okay? Anyway, I'll let you carry on with the rest of the